Welcome to Science Made Easy channel. A channel you will not want to miss.
This is Science Made Easy channel. Don't forget to subscribe. We are here again. So we're looking at what are we here for again? See chemistry. So today we'll be talking about the kinetic gas equation. Talking about the kinetic theory of gases. So talking about the kinetic theory of gases. So when you hear the word kinetic means what? Movement. That means we'll be talking about the movement of gases. So the solid, liquid, and gas are actually classified according to their movement of gas. According to their movement. So that you see this kind of question before in JAMB objective question, but so that the solid, liquid, and gas are classified based on their, not based on their shapes. They are classified based on their their movements. Their movements. So that means we have the three states of matter. And what are the three states of matter? Solid, liquid, and gas. So at this point, now the solid, what do we call the solid? So we all know that when you're talking about the solid, their particles are closely packed together. The particles of solid are closely packed together. So it restricts their movement. It restricts their movement. So they cannot move. So that is why that solid does not move, because there's a restriction in their movement because of the structure. Because of their structure. So solid, they are closely packed together. The particles are closely packed together. So another thing you can know about a solid is that they are very hard to compress. Why are they hard to compress? Because their particles are closely packed together. Another thing you have to know about the solid is that solid have a definite shape and definite size. So you can actually determine the shape of any solid. For example, if I take this bottle now, I can tell you the shape of this bottle. And how can I tell you the shape of the bottle? I can use this cylinder here. There's a cone here. I can calculate the volume of the cone. I can calculate the volume of the cylinder. Then I can get the shape of that solid. So the shape of any solid can actually be determined. So they have a definite shape and definite volume. And you can also determine the volume. I can determine the volume of this something I've told you. For example, a cylinder. What is the volume of a cylinder? The volume of a cylinder is pi r square L. So you can actually determine the volume. So another thing that they are on the forces that bound solid together are very strong. The force of cohesion that bound from solid together are very strong. So another thing we have is the liquid. So talking about the liquid, their particles are slightly apart from each other. That is why they can still move. Talking about a liquid, their kinetic energy is still somehow high a little bit, because their particles are somehow slightly apart from each other. So a liquid can actually move. And that is why if you pour water on the ground like this, the water can spread. So because it can actually move, because the particles are not that close together compared to that of solid. So another thing is that liquid have a definite volume. I can tell you the volume of the water inside this place now. So if it was calibrated, I can tell you that okay, the volume of this water is about 50 centimeter cube, or I can actually tell you the volume of the water, but it does not have a definite shape. So if I pour a water inside this place now, the shape of this water is the shape of this container. So it does not have a definite shape. If you actually take the shape of the container, so it does not have a definite shape. So that we're talking about our liquid, but they do not have a definite shape. So they take the shape of the container. So another thing is that the force of cohesion between the particles of liquid, they are not as strong as that of solid. That means they are somewhat weak compared to that of solid. So let's move to gas. Talking about the gas, the particles of the gas are farther apart from each other. So that is why gas is the fastest. Gas is the fastest state of matter. Their particles are farther from each other. That is why I think I forget the country. They can destroy the whole world in a day. Why? They can just release the gas, because gas moves at a very faster rate because they through diffusion. So if I pollute the air now, like I just pollute the air, immediately so if it's a pollution that was very strong, you understand? So someone even near me or someone at that age can actually get immediately, because gas travels very fast, even compared to all other states of matter. And gas does not have a definite shape, does not have a definite volume. If there's no water inside this, if there's no water now inside this bottle, what happens is that what is inside this bottle is a gas. What is inside the bottle is a gas, because there's nothing inside it. What is filled inside is a gas. So it actually takes the shape. That means the shape of the gas is the shape of this bottle. The volume of the gas is the volume of this bottle. So that is why a gas does not have a definite volume, does not have a definite shape. It actually takes the shape and the volume of the container. So moving further to the so let's talk about the gas law. So we are moving to the gas law like that. Okay, we also have the change of state. Let me talk about the change of state. Let me talk about the change of state. So let me talk about the change of state. So we have different change of state. That means the change of state is telling us how the solid is being converted to a liquid, the process that is at which it's converted to a liquid, the process that the liquid is being converted to a solid. So for example, let's say that these are solid. So our video will be somewhat short today. I mean, it's not that too short, but let me test. So let's say these are solid is here. Liquid. No, let me write gas there. Let me write gas. Let me write liquid in the middle here. So if there's a conversion from liquid to from solid to liquid, it's called melting. That means if a solid is being converted to a liquid, it's called melting. Let me use the test. I think the test will be more faster. So this will be my liquid. This will be my melting. Melt. So if our solid, the solid being converted to liquid, that is melting. And if it is from liquid to solid, from liquid to solid is what I would call the freezing. So that process is called freezing. And from liquid to gas, if a liquid change to gas, we call that one what? Condensation. We call that one condensation. Condensation. And from our gas to liquid, no. From our gas to liquid, we call it gas to liquid is what? Oh, sorry. There was a mistake here. This one from our liquid to gas is what we call our liquid to gas is evaporation. Our gas to liquid is condensation. So sorry about that. But our liquid to gas is evaporation. Is evaporation. Evaporation. So, and our liquid, solid to gas, our solid, sorry, our solid to gas is sublimation. So this is what we call the change of state. Or gas on solid to gas, we call what? Our sublimation. Sublimation. So these are change of states. So as all those things are changing, the process. So if the liquid change to a solid now, that is freezing. A solid change to liquid, that is melting. Liquid change to gas, that is evaporation. And gas to liquid, that is what condensation. And solid to gas sublimation. So be the ending here for today. So thank you. Thank you for watching Science Made Easy. Bye. Don't forget to subscribe.